Welcome to this explainer. Today, we're launching a deep dive into something you've probably noticed yourself, the frankly terrifying rise in natural disasters over the last couple of decades. I mean, if you feel like every time you check the news there's another headline about a devastating hurricane, a massive flood, or out-of-control wildfires, well, you're not imagining it. We're going to look at the hard data to figure out exactly what's rewiring our Earth's natural systems.
So let's just get right into it. The big question. Are all these events just a streak of incredibly bad luck? Is it purely a coincidence that we're seeing so many catastrophic storms and prolonged droughts? Or are we looking at the direct consequence of a shifting global climate? To figure that out, we really have to zoom out past the daily headlines and look at the big, historical trends.
And our first massive clue comes from the Center for Research on the Epidemiology of Disasters. Get this, the annual global occurrence of climate-related disasters has more than tripled since the 1970s. Just pause and think about that. 3 times as many disasters. We're seeing Category 4 and 5 storms popping up way more often in places like the North Atlantic, and wildfires in California and the Amazon that just burn longer and spread wider. This definitely isn't just some random bad luck.
To really grasp the stakes here, we have to look at the economic toll, which is just staggering. Over the past decade, annual damages from climate-related disasters have regularly blown past the $200 billion mark. $200 billion every single year. The human and economic costs are absolutely massive. So, this isn't just an environmental issue anymore. It's a very real threat to global economies, our food and water, and everyday human livelihoods.
So, with stakes literally that high, we need to identify what's actually driving this surge. Let's look at Section 1, the suspect and the MO. According to the incredibly detailed 2023 IPCC report, human activities, we're talking burning fossil fuels, deforestation, massive industrial processes, they've already pushed the Earth's average temperature up by about 1.1 degrees Celsius above pre-industrial levels. Now, 1.1 degrees, that might sound like nothing, right? If you tweak your living room thermostat by a degree, you don't even notice. But on a planetary scale, this long-term rise is enough to completely rewire our massive atmospheric and oceanic systems.
Now you'll hear this argument all the time. Well, the weather has always changed. And hey, that's true. Natural weather variability has always been a thing. But human-induced warming is a totally different beast. It acts like a chemical accelerant. It basically takes those normal, natural systems and cranks up the environmental feedback loops. So what would have been just a typical storm or a regular dry season gets pushed to the absolute extreme.
So how exactly does a slightly warmer planet actually translate into a burning forest or a flooded city? Let's move to Section 2, the mechanisms of destruction.
The scientific evidence essentially maps out 4 distinct mechanisms. Think of these as the modes of operation, where warming directly fuels extreme events. It boils down to warmer oceans, changing precipitation, rising sea levels, and ecosystem stress. Let's walk through exactly how each of these gears turns to create the literal disasters we see on the news. Let's start with the first one. You can really think of warmer oceans as high-octane engine fuel. Tropical cyclones literally pull their energy from ocean heat. So as the sea surface temperatures creep up, those storms are drawing in all that extra thermal energy. And the result? Storms that are way more intense, packing much higher wind speeds, heavier rainfall, and those absolutely catastrophic storm surges. The ocean is quite literally feeding the beast.
At the exact same time, we've got the second and third mechanisms working in the background. A warmer atmosphere physically holds more water vapor. It acts like this massive, growing sponge in the sky, which ends up triggering much heavier, more frequent rainfall. And that means severe floods and landslides. And while that's happening up above, down below, melting ice caps and the actual thermal expansion of seawater, because water expands when it gets warmer, are raising our coastlines. That just magnifies the destruction anytime a storm surge hits a coastal town.
All right, so we've talked about the theory. Now let's look at the hard reality in Section 3, the evidence, real-world disasters.
The escalating pattern here is just undeniable. Back in 2005, Hurricane Katrina was supercharged by unusually warm Gulf waters, causing over $125 billion in damage. Then, by 2013, Typhoon Haiyan became one of the strongest cyclones ever recorded, absolutely devastating the Philippines. Fast forward to 2019 and 2020, and our fourth mechanism, ecosystem stress, kicks in, causing record-breaking heat and drought that burned over 18 million hectares in Australia. And then, in 2021, that atmospheric sponge effect we just talked about dumped historic rainfall, causing catastrophic flooding across Germany and Belgium. The evidence is literally everywhere we look.
But here's a twist in our investigation. The climate? it isn't working alone. Let's look at Section 4, the accomplices, human factors. To really get this, imagine a storm hitting a totally natural, resilient ecosystem versus one hitting a highly vulnerable human system. In nature, things like forests and wetlands act as natural sponges. They absorb the water, their roots hold the earth together. But human activity, like massive deforestation, strips away those vital natural barriers. We're removing the soil's anchor, so we end up turning what should have been a heavy but totally manageable storm into a deadly landslide.
And honestly, it goes way beyond just cutting down trees. Poor urban planning, like building sprawling neighborhoods right in the middle of natural floodplains or exposed coastlines, drastically skyrockets our vulnerability. Add in some outdated, inefficient infrastructure, and these human factors basically team up with the changing climate to multiply the property damage and, tragically, the human casualties. We are essentially putting ourselves right in the crosshairs of the danger we're accelerating.
So, having laid out our suspect, the mechanisms, the accomplices, and the hard evidence, it's time to deliver our findings. Section 5, the verdict and future forecast.
The real crucial point here is this pretty chilling forecast. Under our current emission trajectories, scientific models from the IPCC predict that global temperatures could jump by 2 to 3 degrees Celsius by the year 2100. Now, remember the chaos we are already seeing today with just a 1.1 degree increase? Doubling or even tripling that increase? That means the storms, the floods, the droughts, and the heat waves are projected to become severely more frequent.
And if that happens, the social and economic fallout is going to be devastating. Vulnerable populations, especially in lower-income countries, are going to face incredibly disproportionate risks. We're talking about millions of people being forced to relocate, triggering mass human displacement as coastlines literally disappear underwater. On top of that, the increased droughts and floods will completely scramble global agriculture, posing a massive threat to our worldwide food and water security.
But it's not all doom and gloom. Fortunately, our investigation also highlights the solutions we need to protect ourselves. Let's look at our final section, mitigating our future risks.
To actually mitigate these risks, the research points us toward 4 essential, coordinated actions. First off, we absolutely have to slash greenhouse gas emissions by shifting toward renewable energy and sustainable transport. Second, we need to go all in on ecosystem restoration, bringing back those forests, wetlands, and coastal mangroves so they can do their job and act as natural buffers again. Third is climate-resilient infrastructure. We have to build our cities from the ground up to actually handle floods and extreme heat. And finally, putting advanced early warning meteorological systems into place will save countless lives when the extreme weather does inevitably hit.
I want to leave you with this final, inescapable takeaway drawn straight from the research. This surge in disasters? It is absolutely no coincidence. Human-driven global warming has created a direct causal relationship with extreme weather, and it demands our immediate attention. Proactive intervention is literally our only path forward if we want to safeguard lives, our ecosystems, and our economies. So, looking at the data, the question really isn't if our world is changing anymore. The real question is, will we adapt our behaviors and our infrastructure fast enough to survive the storm that we've helped to create?